Light rays from the object you're viewing enter the lenses on the far end, the objectives. This projects an image just behind those lenses, inside the binocular's housing. The smaller eyepiece lenses you peer through then magnify that image. The objectives are curved, causing the image to appear upside down. To turn it right side up, each binocular half needs a glass prism. Using UV light-activated glue, workers mount several prisms on steel plates that take them through a series of grinding and polishing steps. Protective paint prevents any dust from contaminating the pristine surface. Grinding with diamond dust removes mere tenths of a millimeter of glass. Polishing with an even finer abrasive removes another 1/100th of a millimeter. At the end of it all, the three sides are perfectly flat. This minimizes reflection, critical for making the glass see-through. To make each prism, they glue two pieces of glass together at 90 degrees. This special machine ensures the angle is precise. A shot of UV light dries the glue. The first piece of glass rotates the inverted image 90 degrees. The second rotates it another 90 degrees, completing the flip. Now for the objectives. These curved lenses have undergone the same grinding and polishing steps as the prisms. Now they go through a 9-stage computer-guided cleaning process. After inspecting the lenses, a technician glues two together. A double lens limits a type of distortion that causes fringes of color to appear around the image. It's critical to match them to each other perfectly. If the alignment's off by more than just 1/100th of a millimeter, the image will be poor. This alignment machine displays a dot representing the center of each lens, so it's just a matter of matching the dots. A 2-second shot of UV light dries the glue. Next, a technician loads mineral pellets into a vacuum chamber. Their exact formulation is a company secret. The pellets produce an anti-reflection lens coating that lets more light come through the lenses. Inside the vacuum chamber, a beam of electrons evaporates the pellets into microscopic particles that coat the lenses. It's time to begin assembling the binoculars. First, the objectives go into the housing, which is usually made of plastic, aluminum, or carbon. Workers clean the lenses with a few blasts of compressed nitrogen. Then secure them in place with threaded holding rings. Now a few drops of glue behind the objectives, where the prisms will go. Another blast of nitrogen to remove any dust. Then they insert the prisms. This optical machine aligns the focal points of the prism and its corresponding objective. Then some more glue to lock in the positioning, and a blast of UV light to dry the glue. Now they silicone the objectives and prisms to the housing's middle section. Silicone creates an airtight and waterproof seal. This holding mechanism presses the parts together while workers drive in the screws. Onto the opposite end of the middle section go the oculars, the smaller lenses through which you look. Those also attach with threaded holding rings. Now, through a valve on each side, a machine sucks air from the housing and injects nitrogen gas. Nitrogen prevents the lenses from fogging up. A day after filling, they recheck the nitrogen pressure to make sure there's no leak. This factory puts all the binoculars it produces through rigorous testing, subjecting them to prolonged vibration, water pressure, extreme heat, freezing temperatures, and other trying conditions. After every test, inspectors make sure everything still works perfectly, both mechanically and optically.